have the particle size in the range of 1 nanometer to 100 nanometer. If the size is in the range of 1 to 100 nanometer, we call it the colloid. If larger than 100 nanometer, we call it the suspension. If less than 1 nanometer, we call it the true solution. So okay, so this is the boundary line between the three type of solution. So in the previous class we have discussed all these things. So what are, you can see what are the properties of the solution, colloid and suspension. So particle size, already I have told you, true solution have a particle size which is less than 1 nanometer, while the colloids have a size 1 to 100 nanometer, while the suspension more than 100 nanometer. So this is the first property, which is called the particle size. So you can see the colloids are in middle of the two, suspension and the true solution. So it's stand at the middle of the true solution. So how is the appearance? So true solution, for example, if I told you that when you dissolve sodium chloride in water, so you will get a clear solution. You get a clear solution of sodium chloride. So you can see. But in the case of if you remember, I told you in the case of suspension, while in the case of colloid, you can see cloudy. The solution is cloudy because the particle size is bigger. When the particle size is bigger, automatically the color also changes. So this is cloudy, while in the case of suspension is also cloudy. I give you the example of milk. You can see milk is cloudy, as whitish. You can see homogeneity. How true solution? You can see the particles are homogeneously dispersed in all in the mixture. So they are the homogeneous. While in the case of collides, this may be homogeneous or heterogeneous. Homogeneous means which is which is distributed uniformly, while heterogeneous, for example, if we centrifuge it, so the fat molecule or the butter molecule will settle down, so you will not then it is not homogeneously distributed. And then heterogeneous, you can see the sometimes you can see that ice cream or the color is very dark or something like this, they may be heterogeneous. Okay. Transparency, true solution are transparent or colored.
Excuse me, sir.
Yes beta.
सर स्लाइड शो नहीं हो रहे.
Sorry.
स्लाइड शो नहीं हो रहे.
अच्छा, ये तो मैंने ऑलरेडी शेयर किया हुआ है, पता नहीं, मैं दोबारा शेयर करता हूँ, एक मिनट। क्या मसला है? तो ये बाकी लोग सोए हुए हैं, तो वो कह नहीं सकते कि स्लाइड्स नहीं शो हो रहे हैं।
सर हम समझ रहे थे कि आप जनरल डिस्कशन कर रहे हैं।
नहीं बेटा, मैं तो आपको ये स्लाइड दिखा रहा हूँ।
ओके सर, ओके, थैंक यू।
अभी क्लियर है? आ गया?
यस सर।
सर ये स्लाइड्स जितनी भी है ना सर पीडीएफ में, सर आप अगर शेयर के साथ
मैं आज कर देता हूँ बेटा, आज कर देता हूँ, ठीक है, डोंट वरी। Okay, is it clear now?
Yes sir, it is clear sir.
Okay, so I said the particle size is, you can see there is particle size is given 1 nanometer, and if in the range of 1 to 100 nanometer, we call it the colloid. If more than 100 nanometer, we call it the suspension. Also, you can see appearance, homogeneous solution, the true solution are clear. You can see when NaCl is dissolved in water, or sugar is dissolved in water, you can see clear solution is obtained, while the other two are cloudy because you can see the particle size is greater. Also, in the case of homogeneous, the particles are evenly distributed. I mean, they are uniformly distributed after a long time also there. While in the case of while in the case of colloid, the particle may or may not be. In the case of suspension, they are heterogeneous. Okay, while transparency, in the case of true solution, the solution is transparent. You can see, but some are colored depending on the salt. For example, if zinc chloride or cobalt chloride is dissolved in water, you will get a colored solution. So they may be transparent or colored. While in the case of often translucent and opaque when can be transparent. For example, milk, you can see milk is opaque. You can see the milk, you can see, while also in the case of suspension is opaque because the particle size is bigger. These are these are the properties we are comparing. While separation, in the case of two solution, the components are not able to separate by any, or for example by distillation or something. You can see does not separate, while in the case of colloid can be separated. When you centrifuge it, you can see the butter will get down, while and the water will become on the top of the on the butter. While in the case of suspension, separation are settled, so after some time they get separated. Okay, filterability passes through filter paper. You can see the solution. If you make a solution of sodium chloride, if you put on the filter paper, it will go through. While in the case of passes through filter paper, but in the case of ultra, I mean the very micro filter paper, it doesn't passes through. So the collide also passes because the particle size is less than. If the size of the filter paper is less than 1 nanometer, then automatically sorry, is greater than 100 millimeter, they will pass. If less than, so automatically they will trap. So particle do not passes through filter paper in the case of suspension. You can see the ice cream. These are the example. Okay, so this is the property. So these are the example: blood, jam, shoe polish, smoke, etc. These are the colloids. Okay, mel, synthetic polymer, fog, blood, jam. Blood, you can see blood, the human blood. If you centrifuge, automatically they will get separated. Okay, so these are the example you can see. These are the example of colloids: milk, polymer, synthetic polymer, blood, jam, shoe polish, smoke, etc. are the example. This clear or not?
Yes, sir, it is clear, sir.
Very easy. Nothing there is, I mean, difficult. Okay. How to prepare the colloid solutions? So these are the method. There are two main methods. One is called the condensation methods, in which the particles present in the true solution, atom, ion, and molecules, are allowed to grow in size to the particle size of colloids. I mean, when in the condensation method, how to make the colloidal solution? For example, we have a true solution. Then what we do, we allow the particle to grow to the size of the colloids. This is the condensation. We call it the condensation. Condensation means the particle get together. I mean, we call it the seeding. We call it another word which in the chemistry is used is the called seeding. And which, for example, one atoms in the case of solution, true solution, there is one atom. But while in the case of, if we condense them, so these atoms get together, and then they make a larger molecule. Then we call it then automatically the size will increase to the colloid. For example, before it was 1 nanometer, so they are allowed to grow, or they are allowed to condensate. Then the particle is in the range of 1 to 100 nanometers. So the condensation method is in which the particle present in the two solutions, atom, ion, and molecules, are allowed to grow in size to the particle size of colloid. Second is dispersion method, in which the bigger molecules are broken to the particle of colloid dimension. Means the particles are bigger, and in the first one the particles are very small. They are allowed to grow together. They are allowed to combine together to make a larger molecule. While in the case of second one, dispersion, the larger particle is broken into pieces to make the particle of colloid. So okay, this clear or not?
Yes, sir.
Okay. Now, this is preparation of colloid method. The first condensation method. What are the how many condensation method we have? The first one is reduction. Reduction is generally we call it the addition of hydrogen or removal of oxygen. Generally, we call it the reduction. Or gaining of electron is called reduction. This is the simple example. This is the simple definition: addition of hydrogen or removal of oxygen or gaining of electron is called reduction. This method involves the reduction of soluble salt of metal by using reducing agent. For example, gold sol can be obtained by reducing a dilute aqueous solution of gold with stannous chloride. You can see MaUCl2 plus SnCl2 when they react together. So you get the gold particle. S chloride is also obtained. So you can see reduction in the condensation. You can see there is condensation. So you will not get a single gold molecule in the atom, but large number of gold atom, and they will combine together to make a sol. Sol is a liquid suspension of the particle in the range of 1 millimeter to 1 micron. So this is the range for the solvent. Okay, this clear?
सर ये सोल पर समझ नहीं आई.
Sol, just like a colloids, which have the particle size in the range of 1 nanometer to 1 micron. If the particle size is in this range, we call it the sol. Sol is a liquid suspension. Liquid suspension means just like milk. Liquid suspension, in which the particle size is in the range of 1 nanometer to 1 micron. Now clear or not?
सर ये बात स्टूडेंट कहते हैं कि हमें लो करें.
उनको कह दे कि जल्दी थोड़ा सा जल्दी भी उठा करें, क्योंकि बार बार हम तो उसको माइक को नहीं कर सकते, मतलब मेरी माइक से नहीं कर सकते बेटा.
ओके सर.
This clear? Reduction is clear or not? Hello? Hello?
जी सर सुनिए तो
Hello? Hello?
Yes, sir.
Is clear or not?
Yes, sir.
yes sir
Yes,
it is
sir.
clear.
Okay. So the second, in the reduction, addition of hydrogen, removal of oxygen, or a gain of electron. You can see AuCl2. So chlorine is negative while Au is plus 2. You can see while after the reaction, you can see Au comes to 0. So it means it has gained electron. So this is called also reduction. So gold atoms are produced. So this is also reduction method. This is the first method of condensation. Second one is oxidation method, which is the opposite to reduction. The addition of oxygen or removal of hydrogen or loss of electron is called oxidation. You can see example is, you can see colloidal solution of sulfur can be prepared by oxidizing an aqueous solution of H2S with a barium suitable oxidizing agent such as Br2. You can see H2S plus Br2. So after that, you can see sulfur before. You can see sulfur is H2. H2 is minus 2. Sulfur is minus 2. While hydrogen is, just tell me H2S. This is the hydrogen has negative or positive? Valency.
सर पॉजिटिव है H2S में.
H2S में पॉजिटिव है या नेगेटिव है?
ये S नेगेटिव है और H2 पॉजिटिव है.
Okay, so plus Br2, when Br2 oxidize, so you can see sulfur is produced. So you can see sulfur gain. Now you can see S is just tell me sulfur is, if this is negative, for example, this is, just look at here, S is negative. So how it have lost the electron. So is called loss of electron is called
Oxidation.
oxidation. You can see H2S, loss of the addition of oxygen or removal of hydrogen. You can see H2S. So hydrogen is there with sulfur. So you can see hydrogen has been removed. You can see and become to zero valent. So this is also another method which is used to prepare the colloidal of the sulfur. Okay. So this is the second method. Again, H2S plus O2 oxygen. You can see again H2O is produced while sulfur is produced. So this is called the oxidation method. So the first one is reduction, and the second one is oxidation. The chemical agent is used to oxidize the material. For example, H2S. You can see this clear or not?
Yes, sir. Clear.
Okay. Third method is hydrolysis. Hydrolysis, the split up of water molecule is called hydrolysis, in which the water molecule split up. So this method is used to obtain the sole of oxide or hydroxide of weakly electropositive metal. I mean electropositive, which have later tendency to electropositive to last electron. This got the weakly electropositive metal, such as iron and aluminum. So sole of ferric hydroxide and aluminum hydroxide can be prepared by boiling the aqueous solution of the corresponding chloride. You can see when we, for example, FeCl2, water H2S. So again, this is H2O. Sorry, this is H2O. This is H2O. Sorry, because this is aqueous solution. FeCl3 plus H2O, not S. So this goes to FeOH taken 3 plus HCl. This clear or not? Hello.
जी सर
This clear or not? Iron chloride, when aqueous solution of iron chloride goes under hydrolysis, so ferrous hydroxide is obtained, while in the second is HCl. So this is the method which is used to prepare the colloids in which the water molecules split up. So if this is sole of ferric hydroxide and aluminum hydroxide can be prepared by boiling the aqueous solution of the corresponding chloride. So if ECl3, automatically it will have H2O. This is H2O, not H2S. Okay. So when we boil it, when we provide heat, so automatically they will convert it into hydroxide. FeOH taken 3 plus HCl. Okay. So another method is double decomposition method. Double decomposition method means in which both the salt decomposes, in which both the salt in which the ions of both the salts separate and react with each other. For example, HCl plus NaOH. So HCl NaCl plus H2O is produced. So this is called the double decomposition method. If you remember, these are the method things. So in the double decomposition, you can see As2O3 plus H2S. So automatically you can see As2S3O8 taken 2 plus water is produced. Okay. So the sole of inorganic soluble such as arsenic sulfide, silver halide, etc. may be prepared by using double decomposition reaction. So in which the ions of the salts exchange with each other. You can see they exchange their ions with each other. So this is called the double decomposition method. Is clear or not? Hello.
सर ما ته کلیر دی او دا نور راته پته نشته ټول خاموش دي نو
بچو ولې دا څه چل دی ډېر بدحاله یې تاسو خو نن female.
Sir, clear the.
Okay, the last method which is used to prepare the prepare the colloid is exchange of solvent. Suppose this method is based on the principle that if a substance A is insoluble in one solvent X, for example, we have a salt A and we have two solvent A and X and Y. If A is insoluble in one solvent, suppose that this is X, but soluble in another solvent, say Y. What we do, then the colloidal solution of that substance is prepared by dissolving substance A first in Y, because it is soluble in Y. And then what we do, we pour excess amount of the solvent X, which is not, in which it is not soluble. The sole of the sulfur as phosphorus is prepared by first dissolving in alcohol and then pouring excess amount of water. So if we have one salt, for example A, and we have two solvent X and Y, if A is insoluble in one X, while soluble in the another, which is Y, what we do, first we prepare solution in the soluble one and then we pour the solution into the insoluble one. We will come with the colloid. I mean the particle size will the particle size will come in the size of the colloid. It means in 1 millimeter to 100 millimeter. The sole of sulfur of phosphorus is prepared first by dissolving in alcohol and then pouring into excess amount of water. So this is, I mean, exchange of solvent. Just we change the solvent. If one is soluble in one, and if substance is soluble in one solvent, what we do, we prepare the solution, and then what we do, we take the solution and prepare and then pour into the solvent in which the same substance is not soluble. So we come with the colloids. So these are the 5 methods which is used to prepare the colloid by the condensation method, and make the particle size grow to the particle size of the colloid. Because the true solution, we first make true solution and then we allow them to grow to the particle size of the colloids. So these are the 5 methods. Any question, please?
सर د थर्ड नंबर کې स्टूडेंट ته لګ مسله دا ورته لګ اگین وکړي
Third one,
یس سر
hydrolysis means splitting of water. For example, we have a solution of FeCl3 aqueous solution. This is H2O, not H2S. This is H2O. नीचे देखें जो रिएक्शन लिखा हुआ है इसमें H2O है, मैं अकॉर्डिंगली चेंज करूंगा, लेकिन आप इसको H2O कंसीडर करें. फॉर एग्जांपल हाइड्रोलिसिस मेथड, if for example we have if iron chloride solution, aqueous solution, what we do, if you want to prepare the colloid, we heat the solution. So upon heating, it will crack, the FeCl3 molecule will crack down, the chlorine will be released, and then iron hydroxide will be formed. Hydrolysis will occur, in which hydrolysis is a process in which any material react with water by splitting its molecule. For example, H2O react with FeCl3, so iron hydroxide is formed. So you can see water molecule is there, which split into opposite ion and then react with iron to form its hydroxide. So sole of iron hydroxide and aluminum hydroxide can be prepared by boiling the aqueous solution of the corresponding chloride. So already I have this method is used to obtain the sole of oxide or hydroxide of weakly electropositive metal such as iron, aluminum. Sole, then I define what is sole. Sole is a solution in which the particle size is ranging in 1 millimeter to 1 micron. If the size is in the range of 1 millimeter to 1 micron, we call it the sole. This clear or not?
यस सर इट्स क्लियर सर। ये आखिरी वाला थोड़ा समझाइए सर ये।
ये एक्सचेंज ऑफ सॉल्वेंट है। फॉर एग्जांपल आई सेड एक्सचेंज ऑफ सॉल्वेंट हमारे पास, if we have one solvent, we have a substance A which is insoluble in one solvent X. If we have two solvents X and Y, if substance A is insoluble in X and soluble in Y, what we do first, A is dissolved in Y, you will come with a true solution. Okay, A is dissolved in Y, you will come with a true solution. Then this solution is poured into an insoluble solvent, for example X, so which is in which the substance is insoluble, so we will get the colloids. Just read it, very simple. If you read it,
Sir,
यस सर
example
क्लियर
Raki,
सर।
sir, general example, sir.
this is the soul of sulfur or phosphorus is prepared by first dissolving in alcohol and then pour into excess amount of water. This already I have wrote the example. For example, just simply let me explain it. Don't worry about it. Okay, 8 minutes. A is insoluble in solvent. Can you see?
Ji, sir.
Okay, this is A is soluble in solvent Y. Ab, I have wrote A is insoluble in solvent X, while A is soluble in solvent Y. सही रहा? पुपुष में
Ji, sir, पूछो sir.
first dissolve in Y to make true solution. Is clear or not?
Ji, sir, clear, sir.
A goes dissolve. एक मिनट अब wait. And Y. When you A dissolve in Y, because A is soluble in Y. Now, second, pour this solution into X. You will get colloids. Now clear or not?
यस सर क्लियर।
A डिसॉल्व करे फर्स्ट Y में, इसी सोल्यूशन जब ये ट्रू सोल्यूशन बन जाए तो ये ट्रू सोल्यूशन X विच इज इनसॉल्युबल फॉर A इसमें डाल दे तो आपका कोलाइड बन जाएगा।
Ji, sir, clear, sir.
ओके सर थैंक यू।
Okay?
Thank you, sir.
Any
Thank you
question?
very much.
So question क्या बच्चों?
ना सर नहीं चले सर।
सर ये स्कैटरिंग इफेक्ट भी कोलाइड में शो होता है।
बेटा सबको हम डिस्कस करेंगे, ठीक है? सबको हम ये कर देंगे। ठीक है,
ओके सर, ओके सर।
डोंट वरी, एक हर एक उसको हम करेंगे एक एक। क्योंकि उसका पार्टिकल साइज उनका बड़ा होता है तो स्कैटरिंग करेगा। फॉर एग्जांपल सॉल्यूशन में वो पास होगा क्योंकि द पार्टिकल साइज इज लेस। द वेवलेंथ, वो वेवलेंथ की बात होती है, तो वो वेवलेंथ वो बड़ा होता है और पार्टिकल साइज बड़ा होता है, उसको स्कैटर करेगा। और ये ट्रू सॉल्यूशन देखें उस पे पास होता है क्योंकि द पार्टिकल साइज इज वेरी वेरी स्मॉल, द रेज कैन पास थ्रू। तो ये अलग चीजें, तो उसको हम डिस्कस करेंगे। ठीक है,
ओके सर।
ओके। अटेंडेंस मुला गवाले बच्चों।
सर अटेंडेंस डन सर, बस दी तो आई लीव कई।
ओके, लीव द
Sir,
ग्रुप। हाँ
sir,
हाँ, वाह
sir, most of
सर
the slides, sir, the final, the khama sent के नंची
बच्चों
मंगदा the study शुरू को।
उस दवा तक के ना बच्चों तास से कॉमा सही था।
खजी sir, thank you so much,
अगर
sir.
कदा से वाई चे सबा मतलब में सबक के लिए क्लास ना वाला इधर बता से इन्फॉर्म कमा सही था।
खजी,
जवान ची दिया वीक से क्लास वाला मा जबर चे फिर खत्म करनो बिया बट टूल पे वजह बनशीन बिया बट ब्रेक तो नाराजी मुझे जो कवाए बा
sir मंगा वायु चिल्ला का study को कुदा लोगों पे topic selection के
बेगम
लिए
और
लगे।
फोन बेगम और हाँ इंशाल्लाह इससे बनेगी। हाँ,
खजी sir, thank you.
ओके, यू वेलकम बेटा। ओके, लीव द ग्रुप बेटा।
सर
हाँ बेटा, वाया
सर प्रिपरेशन और सिंथेसिस में क्या फर्क है?
ये प्रिपरेशन और सिंथेसिस कभी कभार ये मतलब है, हम कहते हैं कि सिंथेसाइज और प्रिपरेशन is usually used for the solution. Synthesis sometimes the word is broadly. For example, we synthesize catalyst. So the solid we prepare, we mix the catalyst, then with the solid material, and we come with the catalyst. Okay. So synthesis and preparation is similar words, but sometimes we specifically use for the catalyst synthesis while preparation for the solution. Okay. For example, we say prepare, and the same is synthesize.